This is AS Module 2, a paper from January 09, and question 3 is on lenses. In part A of this question, you should answer in continuous prose. You'll be assessed on the quality of your written communication. Therefore, your answer must be logical, there must be a flow of information. In all of part A, including continuous prose at the bottom here, and your standard of spelling, grammar and punctuation should be good. So distinguish between a real and a virtual image. In this case, a real image can be formed on the screen. A virtual image cannot. You could also say for a real image that the rays of light actually meet to form the image, whereas on a virtual image it's where the rays of light appear to meet. Part 2 of the question then. A small upright object is placed on the principal axis of a diverging lens. So let's start. We must remember it's a diverging lens. The object is a long way from the lens, almost at infinity. Its image is upright, virtual and diminished, and is very close to the principal focus of the lens. The object is then moved slowly from this distant position to a point close to the lens within its focal length. Describe how the nature, position of the image change as a result. And it also says you may make sketches in the space below to deduce what happens, but you will be credited only for your prose description. So the sketches don't count into the marks. Well, firstly, if it's at infinity, the rays coming from the object will be more or less parallel and will then diverge as they pass through the lens. And you must describe that as it is moved, so how the nature and position of the image change as a result of the movement from that distant position to the point close to the lens. So let's start with, as the object moves towards the lens, the image remains upright and virtual. And also diminished. So no matter where the object is located, the image will always be upright, virtual and diminished throughout the movement. And this is the case for every diverging lens. And as the object moves closer, it increases in height. But is still diminished. So it's always upright, virtual and diminished, and it gradually increases in height as it gets closer to the lens, but still never reaches the height of the object. Part B of this question then. The lens of a projector produces an image of a square slide of side 2 centimetres on a screen 2.4 metres from the lens. The image on the screen is a square of side 0.8 metres. Describe the nature of the image formed in the screen. Well, if it can be formed in the screen, it's real. And judging by the fact that it's a projector, the square slide of the object will be very small, and to produce it onto a screen for people to see, it must be a magnified image. And because we have a real image that's magnified, then we must be using a convex lens or a converging lens. Therefore, the real image will be inverted. So we have a converging lens here, creating a real magnified and inverted image. Calculate the distance between the projector lens and the slide. Well, what information have we got? We've got the size of the object. We have got the screen is 2.4 metres from the lens, so that's V. And the image in the screen is a square of side 0.8 metres, so this is the size of the image. We want to find U. The equation that we have that links all of these is magnification is equal to image size over object size. And that is then equal to V over U. Let's do this stage first. The image size is 0.8 metres. The object size, just be careful here of your units. They must have the same units to make that ratio for magnification. So if our image is in metres, we must put the object size into metres, which is 0.02. This gives us a magnification of 40. Then we say 40 is equal to V over U. So 40 is equal to 2.4 over U. And when we calculate U, we find that it's 6 centimetres. The answer that you calculate when you do this will be in metres, and then you must convert that back to centimetres. So it's 6 centimetres. And there's a mark for that. Hence, in other words, using your previous answer, calculate the focal length of the projection lens. We must use the lens law. 1 over F equals 1 over U plus 1 over V. 1 over F we want to find. U is 6 centimetres, so it's 0.06 metres plus 1 over 2.4. When we rearrange that and calculate it, we find that F is 0.0585 metres, which we then convert to centimetres as 5.85 centimetres. Okay, so to summarise that question, we distinguish between a real and a virtual image. We then described what happens as we move the object closer to a diverging lens. Part B then moves on to a converging lens and asks you again to describe the nature of an image. And using magnification, the ratio of image size and object size to find magnification, and then use that to find the object distance. And then we use the focal length, the lens law, to calculate the focal length of the lens.